So now we'll run through how to use the lumResponse program. So I've launched lumResponse from the Start menu, and this is the window that comes up. You can see it says 16 palette up in the corner. This means it's going to go through the QC 16:2 measurement. It's the default that's selected. This is a default that you can change in a config file. You can also run through a 256 measurement. That's going to measure every gray level throughout the palette. It also has these two modes called the 1786 and 766 palettes. This is for measuring an uncalibrated monitor in order to create a lookup palette in order to generate a LUT and make your monitor follow the DICOM GSDF. For the purposes of this, we'll just go through the QC 16:2 and I'll cover the 1786 in a different video. So with that selected, we'll go to geometry. Here we select the approximate pixel pitch of our monitor of interest. All this does is controls the height and width and the size of the gray square in our image that will pop up here in a second. So for a regular monitor that's just on a standard desktop, this is a fairly approximate but accurate pixel pitch. For something like a 5 megapixel monitor for mammography, we would select the 165. Here we'll leave it at 270. Again, that's the default. We can open up the meter tab, and this loads a number of values that will be used during the acquisition. It defaults to the i1Display Pro, and that's the meter that's currently supported for all future development, and these others are really legacy devices. You don't really need to change any of these values. It'll default to this i1Display Pro, other than this LAM value. And this is your ambient luminance. We assume typically a 0.1 candela per meter squared for a darkish reading room. For brighter areas, technologist work areas, offices, you could put in a larger value. This isn't measured. This is it's just typed in, and that's what will be used for QC analysis. If you have a question on any of these, you can click on the little question mark box. So now that we've got those set, we'll run through how to do a QC measurement. So depending on which monitor you're looking at, you can call the monitor EDIT information. In this case, I'm going to select monitor 2. That's the one I'm currently operating on my desktop. Click on Get EDIT, and this pops up a menu here. You can see where it gives you the monitor description found. You can verify that you're looking at the right one. It gives you the 4-digit serial number and the extended serial number. And so I'll click Yes, use extended serial number. And all that's going to do is it's going to take the manufacturer, the model, and the serial number and put that into the display ID. You could type in anything you want here. You could type in just some words, NICS, desktop, any of these things. All this does is controls the naming, automatic naming of the files that are saved when you're done. So I'll click Get EDIT again and stick with the one that it populates. You can also append to this if you'd like. So if you're doing multiple tests on a monitor, you can put a 1 or whatever after it. So once you have that set up, you can click on Image. It pops an image up, and again, the size of this image is going to be controlled by your inputs, that Geometry tab. For the purposes of this demonstration, these two are going to be overlapping for this video, but normally you'd want this to stay outside, perhaps on a secondary monitor or well to the side of the test box. So you can't see it here, but I have a photometer placed right over top the center of this black box. It's plugged in. It's the i1Display Pro, the same one that we had selected in the meter. And I'm going to click on meter. And it's going to give you a message just saying, is it connected in position in the black square? I said it is, so I'm going to click on yes, at which point it's going to connect to the meter and take some initial readings. You can see the color of these numbers changed, and I'm now getting a reading of the luminance coming off that black square in my photometer. Once that's initialized, I can click on record, and depending on what mode I've selected, it'll go through the steps that we had decided on earlier. So I'll click on record. It'll say that I want to have inserted my DICOM lookup table for the QC mode, and I've turned off my screensavers and the ambient light is minimized. Click on yes, and at this point it's going to start running through each of the gray steps. It goes through some negative gray steps. These are just collecting additional 0 readings. The way the photometer is set up, it takes some time at very low readings to try to get low noise. And as you get to the brighter spots, the brighter gray levels, it'll move much faster because it doesn't need to read for as long. So you can see it's going through the different gray steps. This again is a 16:2. You can read about how this works in our manual. It's sort of a modified quick QC check based on the TG18 18-point measurement. So it's moving along. You can see the color of the gray square is changing. The photometer is reading brighter and brighter levels. And as I mentioned earlier, as it gets through the higher levels, it starts to read faster. We'll let this finish up here. It'll go up through 255. At which point it says it's complete, and it'll ask if I want to view a log file. In this case, I'll say no, you're welcome to. It just shows you the raw readings. I'll then click Save. It'll bring up a dialog box. I'll save it to my desktop. It'll save it in a folder it's going to create based on the name you typed in the folder, based on the name you typed in the display ID. Click OK. And then it's going to save my CLR file. This is my calibrated luminance response for this monitor. It's a text file. I can now analyze the data. It'll pop up a luminance response. Sorry, I'm having trouble displaying all of these in my recording window. Here you can see the luminance response, the measurements versus the DICOM curve, its performance following the curve on the DLL per JND, and then the GNDs per DLL. You can see in both cases it's within the 20% line, which is our internal limit for secondary monitors. And then here's a color tracking box showing you how well the color tracks as it moves to the grayscale, with the center set as the D65 white point. And that's it. That's lumResponse.